All right, lesson 1.5, solving equations and inequalities by graphing. So example 1, we're going to set each side of the equation equal to y. Graph those two equations, and wherever the graphs intersect are your solutions. Well, they already have those graphs graphed there for you. That would be y equals x squared minus 4x plus 1. And y equals x minus 2 in blue, right? Those are those two graphs. Where they intersect is your solution, okay? So if we did it on a calculator, we could trace and see it closer, and we'll do that in a second. But as you can see right here, one, I'll put that as it is at approximately 0.7. and approximately 4.3, okay? When you list your solution, you just list the x, not the y. You're not putting the ordered pair. You're just putting the x value of that point of intersection. The squiggly equal sign is approximately that solution, okay? Earpiece. Okay? All right, so if you look at this next example here, I'll do it on the calculator. We got, I got a sheet right here. After looking at those spots on your calculator, add x is approximately 2.7 and 5.3. If you're to 1/10, right, I'm like, you're completely fine with that, right? Sometimes it's hard to see, but you get that there, okay? So, if we look at this second example here, going to plug it into our calculator. Okay, again, I got approximately negative 3.3 and 1.8 there.
If we are off by like 1/10, is that good?
Yep, that is fine if you're off by like 1/10. Off by a tenth.
I know there's a way to get it exactly where the...
I did 1.5. Okay. So like 1.5, 1.6 in that range. That one was hard to see on that graph when you did it. But something in that range, okay? So what I want to do next here, leave that in. Don't delete that out, all right? Leave those two functions in your y equals section, okay? All right, so on your calculator, we're going to make a table out of those two, okay? Next part here. All right, we're going to solve a one variable inequality by graphing. All right, so we're going to get one side equal to 0. So what I did here is I added 2x to get 3x minus 5 is greater than 4. And then I subtracted 4 to get 3x minus 9 is greater than 0. And then the next step is to graph that inequality. So what would be the slope there? 3 over 1. What would be the y-intercept? Negative 9. So I made a negative 9 on that graph. It's off the graph, so I extended it out, made negative 9. I went up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. So I didn't write this whole graph because what we're solving for is where 3x minus 9 is greater than 0. Well, 3x minus 9 is greater than 0 at 3, okay? It's greater than 0 at 3. So x is greater than 3, right? Well, let's say that we were solving for x. Add 9, 3x is greater than 9, divide by 3. Same thing, right? All right, so we are graphing to solve the one variable inequality, but, right, it's the same thing as solving the inequality equation, okay? Algebraically solving for x. So
it's whenever it's positive.
Yeah, yeah. So it's where that line is above the x-axis. Yep. All right, so try to solve the following. So on these right here, like since that's a quadratic, we haven't been over graphing a quadratic. You can put that in your calculator. Do y'all remember factoring at all?
Yeah.
X squared plus 6x plus 5. What are two factors of 5 that add to give me 6?
1
and
and 5. Or 1 is.
Good. Yeah, you're right. You're right.
Yeah.
All right. And so if we set both of those equal to 0, that'd give us our zeros, right? All right. So when we graph this, that's where it crosses the zeros. That's where it crosses the x-axis, right? So that will end up being x is greater than -5 and x is greater than -1. Now, if we look at that on the graph, so if you look at that next example, we want to get everything. I'm going to do that in blue here. We want to get everything. Let's say the left side. X plus 3 is greater than 7 minus 3x. Okay, so if we added 3x, we'd have 4x, subtracted 7, -4. All right, so we'd want to know where that line is above 0. Okay, so if we graph that, this one's easy to graph, right? Like if we had x, y there, 1, 2, 3, 4, and our slope is 4 over 1, so we'd be up 4, right 1. So that line would be positive at x is greater than 1. Oh, I didn't write these answers up here. But you could have also solved that, right? If in the equation, if you had added 4x is greater than 4, divide by 4, x is greater than 1 there. Okay. All right. Last one here. Yes, ma'am.
So on the quadratic, how you wrote x is greater than -5 or x is greater than -1,
Yeah.
wouldn't it be x is less than -5 because it's a parabola?
So our solutions are where it's positive above the x-axis.
Yeah, but it's positive behind -5 because it scoops under it.
So it's decreasing and then increasing, but it's positive above the x-axis. So it's positive above the -5 and above the -1.
Yeah, but it's also positive behind the -5.
So it's like this. This should be x is less than -5. And then I'm gonna erase that there. It should be less than -5. And then okay. Then the last line, x squared minus 4. So again, we can graph that. You can make a table. Couple of different ways to do it. Do you remember doing difference of squares?
Yeah.
What's the square root of the first term?
X.
What's the square root of the second term?
2. You can't do that because it's negative. 2.
It's the only time you can do it is because it's negative. But the x plus 2 equals 0, so x equals -2. X minus 2 equals 0. X equals 2. So you can also add 4. X squared is greater than 4 and square root both sides. And x is greater than plus or minus 2. Okay.
I see.
So, but again, if you had that parabola, if you look, you should have x is less than negative 2 or x is greater than 2 for that parabola. Here, I'm going to draw this on here for my video real quick. So the way that last one would look, 1, 2, negative 1, negative 2, be there, be a parabola going through negative 2 and 2. It's greater than above the x-axis. So that's why it's x is less than negative 2 or x is greater than 2. Okay. All right. On the back of this sheet, do the odds.
It's so boring.
Yeah, they just 36
Like-
numbers. 36 numbers.
All right. Number 1.
I got 38.
4.
It's close enough. So when you
So you could, if you graphed it, it would have intersected at 4. Okay. You could have also solved that one algebraically and gotten it.
38. I think it's 40.
Number 3. Oh, this isn't. You didn't have to do 2.
I did.
I just was. Should have been an X there. You would have gotten negative 12 there. If you want to do number 2, you could.
I thought the first one was. I thought that whole row was 1, and then the second one was 2. Louise says it's 2.
David, they have numbers like every other math every ever gotten.
All right, so you would have gotten 0 and 4 for 3. Okay, 0 and 4 for 3. 0 and 4 for 3. Again, I just did them algebraically. If you do that, remember that if you solve an absolute value equation, you have to set up 2 equations, right? All right, so that's how I did it. You could have graphed it as well. Everyone good there? Any questions there? Okay. All right, so number 5. We got x squared minus x minus 12. So if you graphed that, it should be x minus 4, x plus 3. So then that would be x equals 4, x equals negative 3. So it should be x is less than or equal to negative 3, or x is greater than or equal to 4. If you graphed that, it would have looked like this. 1, 2, 3. 1, 2, 3, 4. Okay.
I thought you said you didn't use any like or equal to.
Well, it had it in the problem, so you do it. Use what it has. Because in this case, in that problem, if you did plug in negative 3, you would get negative 3 squared is 9. All right. Minus a negative 3 would be plus 3, which gives you 12. 12 minus 12 is 0. So 0 does equal 0, right? So negative 3 would apply there. All right, number 7. I graphed it and got approximately negative 2.3 and 3.4. All right, if you're within a tenth, that's fine. Okay. If you're within a tenth, that is fine. And number 9, approximately negative 0.83. If you're within 100th there, that's fine.
I got 7, 6.
That one was really hard to see. Like,
If you want to find an exact thing, you can hit second trace, scroll down to intercepts, and go right by the intercepts and hit enter a ton of times, and it'll tell you.
yeah.
Thank you, Lois.
All right. Then number 11, I got approximately 2.2 and negative 8.8.
Actually, I thought I was.
All right, last right here. DeVitt begins the summer having saved $54 more than Fatima. DeVitt's job pays $825 per hour. Fatima's job pays $9.75 per hour. If they both work the same amount of time each day, how many hours of work will it take DeVitt to have as much money as Fatima? So DeVitt is 8.25 plus the 54 he's saved. Fatima is 9.75. Set up our inequality. So I subtracted negative 8.25x, which gave me 54. It's less than or equal to 1.5x divided by 1.5. So it would be 36 hours worked. DeVitt and Fatima would have the same. Okay. Greater than that or less than that will be more. Really weirdly worded question.